Current flow or electron flow is possible only because electrons can be freed from their electrostatic attraction to the proton of an atom's nucleus. Electrons are freed when energy is applied in the form of heat, light, magnetism, or electricity. The electrons in the partially filled outermost shell determine the chemical properties of the atom. It is called the valence shell. Electrons in outer shells have higher average energy and travel further from the nucleus than those in inner shells. This makes them more important in determining how the atom reacts chemically and behaves as a conductor. The pull of the atom's nucleus upon them is weaker and more easily broken. In this way, a given element's reactivity is highly dependent upon its electronic configuration. It's the valence shell electrons of any element that are crucial for current flow. A material is an electrical conductor when one or more of its valence electrons can be easily freed. Most good conductors have one free electron in their valence shells. Good conductors do not require much force or voltage to free their electrons, thus propagating the flow of energy. The purpose of using conductors is to allow electric current to flow with minimum opposition or resistance. Copper has high conductivity. Gold and silver are also conductive, but they're more expensive and thus not practical in most applications. When electrical current flows in a good conductor, it creates heat or resistance. All conductive materials produce some resistance to electron flow. This resistance is reflected in the form of heat. Non-conductive materials, called insulators, resist electron flow. The important thing to remember about insulators is it takes much more force or voltage to get an electron to leave an insulator's atom than a conductor's atom. Even when enough force is applied to an insulator, only a very few electrons can be released at any one time. Insulators protect conductors from touching each other and protect us from touching conductors. Most materials other than metals are insulators. Plastic, glass, and rubber are commonly used good insulators. Semiconductors are elements that are unique in that they are neither good conductors nor good insulators. This characteristic can be advantageous. Semiconductors can be made to be partly conductive by mixing small amounts of impurities containing free electrons. This is a process known as doping. Semiconductive material, such as silicon and germanium, are the basis for transistors, diodes, and other solid-state devices.